Hello again YouTube. I'm going to show you another smoke ventilation device here. This is a door actuator. I've shown you one of these before. This is another manufacturer's. Again, it's a German manufacturer, but this is a different design, and as you'll see when I open it up that it's got a different drive mechanism. This is one that's come off of a property. The device itself was vandalised. It's quite likely that what's happened is someone's been smoking in a close, or there's been some sort of activation. The doors and windows had opened up, and rather than wait till the next morning or wait until someone came out and reset the system, someone's decided to try and shut the door, and they've broken the chain in this. And I'll show you that when I try to drive it out. Just like the other one I showed you, this one's got multiple cables. You've got 2 power cores, and then you've got 3 other cores here. There'll likely be, I haven't looked at the spec on this one, but it's likely that there'll be one will be common, 2 will control a door lock, and one may be used to feedback whether the actuator's closed or not. It could also be that there's a normally open and a normally closed here for different types of lock. This core here is it's not a cable, it's just a strengthener. It's fiberglass. Because this cable, because it has to be fire rated, or heat rated rather, the cores are coated with silicon FRNC, and it makes them very, very soft. Like you can see that I can basically pull that off with my fingers. So in order to try and prevent any damage, you'll often get another core, and quite often it'll be fiberglass and it'll be coated in silicon, and it helps to keep the cable straight and to give it a little bit of strength. So I'll quickly show you how this works. Again, it's a 24-volt device, so I've got it on the bench power supply, and let's get it driving out. I'll let you see how it works. So just like the other device, you've got a brown and a white core. In this case, I think I discovered the other device used the brown and blue cores, but this has got the more traditional 24-volt colour coding. So the white's the positive and the brown's the negative to drive the actuator out, and you inverse them, so you reverse them to drive the actuator in. So I'll connect this up, and I'll now switch the supply on at 24 volts. So as you can see already, this one has a chain. The chain comes out and it'll fail just very shortly here. You'll see where the chain's been damaged, right here. Oh, it made it past it that time. Oh, no, there we go. There we are. Now the door would be at 90 degrees at this point, and I'll just see if I can show you this, see if it'll focus on this. Right here you can see where the links have been stretched. So this is where the chain was damaged when the door was forced, and it's you can see that I can get my fingernail in between these, so when the mechanism comes out it doesn't ride over that very well. And what effectively was happening when it was on the property was the chain was getting back in, getting stuck at this point, and then the door was jammed open and the property was insecure. So once this has been stretched, there's nothing you can do to replace that, to repair it. You just have to replace the whole unit. And if I reverse the polarity on the power supply, so let's just get the 0 volts on the white and the 24 volts on the brown. It'll try and drive back in. Now you probably noticed this device here. This is a chain tensioner. Because the chain wants to make its own path, this tensioner keeps it rigid, because as you can see it wants to bow. There we are. Now that's what was happening on the property, and the door was then ajar to this degree. So the chain wants to take its own path because it wants to bend. Now normally it wouldn't bend in this direction, it would only bend in this direction, like so. And this would be rigid. So to keep this rigid and get the door to 90 degrees without the chain folding out, they use this device here, and it's just a spring tensioner with a brass key on it that keeps the chain straight. As the chain comes in, it has to fold round, and then it folds back on itself to get this length of chain inside this case. So the chain has to fold in that direction, but you want it to stay straight. If I try and push it there, you see this good section stays straight, and this deals with that. This is just a mechanical device, very simple device. So I'm going to strip this down now. Let's have a look at what's inside this one and see how it differs from the other version we took a look at already. I'm a little bit conscious that there's a lot of spring tension involved here, but I'm pretty sure there's none at this end. I'm sure it's all at the other end where this spring tensioner is. I'm just conscious that I don't put my fingers somewhere they'll get trapped. Okay, there we are. So that's the end with the pivot point in it and the hole for the cable to go through. It's fairly standard for door and window actuators. And inside here, I can already see it, there's a circuit board, but I'll get to that in a bit. Okay, I remembered something I discovered on site when I was taking this off. There's a little hole here, and if you push the chain tensioner in, put a pin through it, so I put a little drill bit in here, it releases the tension on here, and I'm just wondering if that'll let me get the chain back in. I'm not intending on putting this back together, so I'm just going to use an old pair of snips and see if I can get this roll pin out. There we go. Now it seems to have come out okay, but the snips will put little grooves in it, so you could put it back in, but it wouldn't be advisable. Okay, so that's the arm. The arm is just a hollow steel tube, is it aluminium? It feels quite light actually. I think it's aluminium. I can see up here where it's been milled to put this end on. That's the chain end, the chain bracket, and this is the actuator end. And then there's a little roller on it, and the roller just rolls along the door to stop it from damaging it. It's got there's two options. You can either have this push a door directly on the door face, or you can have it pull a door inwards, and there's a bracket, so it's like an L-shaped bracket that comes on the door like this, and you push it, it pulls the door away from the frame. It's now gone to slow state, so the last few degrees, I think it's about 11 degrees, it slows down, and it's basically to make sure that if anyone's standing with their fingers in the door frame, it gives them time to get away, and it reducing the speed, reduces the risk of entrapment. And there it is, away back inside now, and it doesn't know where the end of the chain is. So the chain's actually gone in. You could probably see it in there. The chain's stopped because it's off the end of this cog, but the cog keeps going. Okay, so we've got the chain all the way driven in. I'm going to try taking the tension off of this now. Take that little drill bit out. Okay, so what I'm thinking now is that this is assembled in such a way that it's put on, and somehow this rotation locks it in place, and then this tooth's put in place and the pin is put on. So I'm going to try and remove that pin. but I think, pretty sure the only way I'll be able to do that is by drilling it out. Unless I just destructively remove it. There we are. Aha. So yeah, that's obviously how they do that. They put this on and then fix that tooth in, and they must put this is the tensioning tooth. So they must put this on, and then it looks as if it's very slightly peened over on one side, because you can't get it out once it's in. Very, very slight bulge at the ends. Okay, that's just a milled aluminium plug. Do not remove screws. What's the worst that can happen? I suppose the worst that can happen is I could spring out, jump across the room, ricochet and embed itself in my abdomen. That's probably the worst that could happen. So, or bits come flying out and hit me in the eyes. But I was going to say I'm sure that's not going to happen, but as I'm saying that and I'm turning these screws, there's a lot of tension on them. Yeah, there's definitely spring tension against that. It's plastic as well. Let's see if I can use my weight, my force to hold it in, contain it. There we go. So they were right to say do not remove screws, because not only is that quite dangerous, but you'd never get it back together. But it's quite simple. There's a big spring in there, and then the plunger, and that's it. Okay, now here we have the mechanism itself. This is where the connection's made. I'm just going to take this off. So the power comes in here, and any signalling goes back out there. I suspect that this is the version with no signalling, because there are only 2 cores connected there, unless there's something on the other side. I don't see anything else near it. So when you order these up, there are different versions you order. Now this must be the version that just has the actuator connection. So when you order them, you would order the order code would tell you whether it has actuator only, actuator and door release, actuator and sensor to tell if the door's open or closed, and if there's a delay on it or not. So this is just the actuator connection. On the back there's a diode. Now the diode goes to the 3rd rail here, but that doesn't do anything. The 3rd rail on here is yellow. Now what that does actually do, doesn't do anything in the actuator, but it means that back at the control panel you can use that cable to monitor, you can use that core to monitor the cable. So the voltage will come up, pass through the diode and back to the control panel, and it tells it that the cable's still intact. So that's just a connection board, so let's take that off. Okay, Okay, so the front end here is just the chain housing. This section in the middle is the gearbox. So it takes the drive from the motor and it steps it down and steps it down and down until, so you've got fast rotation here, and by the time it gets to here where it contacts the chain, the rotation is very slow, but in doing so you up the torque. Every time you reduce the rotation speed through these gears, you increase the torque that's available, and that's the purpose of these. Again, you've got metal gears all the way through until you get to the gear that actually connects to the worm drive on the motor, and that gear through the back there, that's the burgundy coloured plastic gear. If the gearbox is going to fail somewhere, it has to have somewhere that'll give way. So that's where it's done, and it's usually done right at the motor. Sometimes you find that all these gears are either steel or brass or aluminium, but actually the worm drive's plastic, so it seems that the safest way to build the gearbox is to have the failure point right back at the motor. I'll just see if I can, there we go, that chain's coming off. It's the pin that releases the chain. Now this last big gear, that just drives directly on the chain, much the way a bicycle chain does. This last gear, set of gears, it's got a bearing both sides, and I'm guessing that's because it impacts the chain, and if there are going to be any external forces, that's the first point that they're going to impact, so you would want a bearing to help take the load on that. The rest of it, you've got a bearing here, again because it's up in this gear, a lot of torque here at this end, a lot of torque here, not so much on this end because it's at the other end, so they've just used a brass bush here, that's fine. And then the gears below that, they're just brass bushed, and there's a little bit of lubrication on each of them. I had guessed that right back up here where it connects to the motor that they would have had bearings on there because of the speed, but as soon as it comes off the motor, you've got a worm drive going directly onto this here. It's a, can't remember the name for this, is a helical tooth, I can't remember, there's a name for this. It's basically slightly offset to fit in the worm drive, so you're getting a big drop down in speed, so I guess that's why there aren't bearings this end. Okay. Right, so a couple of things to note here. This protrusion on the board sits up here. It's reading off this spindle here, the one that goes directly to the motor. This is probably a ferrite ring, and it'll be polarised so that this is a Hall effect sensor. So as that gear turns, this reads the number of rotations. So that's how the actuator knows to slow down when the chain's coming back in, because it knows where it is. There's a tooth. See this? And this would come in and flip up. So this will be for fully extension. So when the chain, I would imagine this would be for when the chain's fully extended. When it's right out, this would hit the limit switch and tell it to stop, because it didn't hit it when I drove the chain all the way in. So I can only assume it's for telling when it's all the way out. I would imagine that when it's all the way in, the stall current on the motor would tell it that it's back in, and that would, it would know that it's reached its closing point. On the circuit board itself, let's just take this off. Okay, so you got inputs for power, inputs for the limit switch, Hall effect sensor. There's a connection here. There was nothing to connect to, so I'm guessing that if there is a lock involved, the lock connection would come off of here, and it would go up to that other board, this one. So you would have additional cables come up here, and there's a little little microprocessor on that side. You got some capacitors, so you've got a capacitor there, looks like a MOSFET, load of diodes and a little choke, and on the other side you've got nothing, a glue dot. I take it that's just to make sure that the pins here don't short out, and this looks like a relay. That little relay would be the relay that you would use for the door lock. So if you want to send a signal to tell a door lock to open, you would use that relay, and it does look as if there's a track on the top here. It goes from that relay round to this header. Another one goes from that pin round to that header. And a couple come from the power connections. So yeah, there'd be power for the relay itself, possibly. Sorry, that's coming to back end of here. So it'd be power for the lock, and then the lock, yeah, so that would make sense. So you'd have 24 volts coming out of two of the pins here, and you would have one of the legs switched through this relay, and then one of the pins would be normally open, one of them would normally closed. So one would apply 24 volts to open the door, and the other one would go to 0 volts to open the door, depending whether you've got a fail open or fail closed lock. Okay, so I'm struggling to make out the text on here. Just a bunch of numbers. But what's interesting is this symbol here. That's a P symbol. It looks like the Pinterest logo, or a back to front Beats logo. That's the same type of motor that was in the other manufacturers. It's the same brand anyway. It had this logo stamped on it, a different label on it. But yeah, that makes sense, because a lot of equipment manufacturers, they might make these bits, and they might make the case and the chain, but they don't actually make the motors. They would just buy that in and assemble it on site. So yeah, that looks pretty good. So yeah, it's interesting that this is the motor is used in different manufacturers. I have looked at a few other manufacturers. In fact, I've got some actuators here that I'll take apart and I'll show you inside. There's a Danish manufacturer. Again, they have their stuff made in Germany, but I know that their motors are different. They've actually got a more compact motor in their units that have got the same power as this, so 1 amp. So I'm guessing that either they're making their own motors or they're getting them supplied from somewhere else. So, like I say, that's this bit here. It's just a chain guide. It's just an aluminium extrusion that helps the chain. So you can see here, as the chain comes out, it extends, and as it goes back in, this guide helps it fold over inside the unit. When it does come out, it will pull out of here. It's just because it's been vandalised, it's a bit bigger than it should be, and it doesn't want to move very well. But yeah, effectively, there you are. It's just a guide. That's it. And that's it. That's what's inside a door actuator. This one, it's hard to say which is more robust. So the version I showed you before, in fact it's still lying here. This one. So this is another manufacturer. Again, German manufacturer. This one's got a big toothed gear here. Let's see if we can drive it out a bit and show you. You know, it's having a think, it's taking some readings, and there it goes. So this one, it doesn't have a chain, it's a big toothed gear, and we had a look inside this, and the gearing, the gearbox that comes up to here is pretty impressive. There's some pretty big gears and some really nicely machined gears. There's a lot of torque this will handle. This unit's rated at, let's see, doesn't say No, it doesn't say. I'm fairly sure though that this unit is rated at 600 newtons. I'm pretty sure it is, because I've purchased one recently. Okay, so this is the rating plate for this one. It's 500 newtons. Sorry, there we go. It's in focus. It's a 500 newton unit, and this one's 24 volts, 1 amp. The other one's 24 volts, 1.25 amps. So that's for how you're getting your additional 100 newtons. So it's hard to say which one is more robust, which one will take more abuse. I've seen a few of these fail in this manner. So basically someone comes along, I'm guessing they're annoyed that the door's open, and rather than reset the system they try and force the door, and the chain gives here. This type here, I've never seen one of these fail at the toothing, you know, at the gears. I've never seen this go. We've only ever seen them go electronically, so either the motor itself fails or the board, the PCB inside fails. This particular one was working intermittently, so don't know what failed. It could be a dry joint, but as they're all surface mount and oven baked, then you'd never be able to tell where it is. The PCBs, in fact you can probably see this one, the PCB has got a coating of conformal fluid, I think you call it. So it's like a lacquer basically. That means that if any moisture gets into the unit, it's not going to affect the PCB. So you're never going to be able to fix a dry joint on a board like this. So yeah, it's they're both nice units. They're slightly different in the way they work, but fundamentally the same thing. There is a significant difference in price though. Probably, I think we're talking a couple of £100 per unit. And there's another manufacturer's come onto the market with a different version of these recently. It's significantly cheaper, and hopefully we'll have a look at that one day, although I haven't come across one yet that I've been able to take apart. Okay, thanks again for watching. If you like this, if you found it interesting, then please like and subscribe, and maybe encourage me to do more.